Yeah. Uh, Good evening, guys. Today I'm going to show you how to analyze airfoils using XFLR software. Let's start now. First, extract the zip file and open the XFLR file.exe. Sorry for the delay. First, we'll start with Xfile direct analysis. Yeah, we generally use this to analyze the already existing airfoils. So let's start. First, it will open up like this. First, we need to design a file. For now, let's just select a NACA file. Um, Let me select 2412. I think you're familiar with the NACA 4-digit and 5-digit file. You can use any of the files, and you can analyze. And okay. Now, before getting to analysis, we need to repanel this. Refine means we need to refine it globally. Design, refine globally. Here number of panels, here panels means just the points. Let me select it as 160 and apply this and overwrite. Okay. Yeah. Uh, Here we have two views. One is file view and one is polar view. Polar file view. First, let's go to file view and we have already designed an ACA file. We actually refine globally to make it more easily analyzable. The distribution of file can make difference in convergence of the file. Now let's load another file. Not I have downloaded another file which is S9000, which is generally used for gliders. One second. You can download these airfiles by just searching in the Google. Here I have searched for S9000, which is generally used for low speed, such as gliders, all the things. Here you can also see the graphs. We'll just analyze this. First, you need to download the CSV file. Sorry, you actually have to download the DAT file. you need to download this. Otherwise, you can just paste it into text file or change it to .dat. Yeah, here you can see the dat file. Now I'll just open up this dat file. Open. Yeah, this is S9000. Now let's just analyze the NACA 2412. Before analyzing, we need to define an analysis. Um, Generally, we'll go with type 1, and type 4 and all other types are generally used for pain analysis. For now, let's just go with 100,000 Reynolds number, and this transition criteria is used when we want to force transition from laminar to turbulent. For now, let's just be a free flow. Okay, and you can see the analysis type here and the file here. Let's analyze this. If you select this, you can see the variation between CP and X. Here is the plot, and let's go to sequence. 0 to 20 degrees, and with the variation of 500, let it be 250, and let's analyze this. Sorry, before analyzing, just select this flow down style, because it will give different colors to the different analysis. Now let's reanalyze this again. Yeah. Now you can see show all ops. You can see all the ops here. Let's analyze this for negative angle also, -8, and let's analyze this. In this polar view, you can see the CL versus CD, all the polars, which we have discussed yesterday. If you can't see this properly, you can change the style and color from here. Now, if you want to analyze for both the files and different Reynolds numbers, to save time, we're gonna do batch analysis, like file list, select both the files, okay, and type 1 and Reynolds number list. From just for now, I'm going with these Reynolds numbers, okay, and here alpha for different angle of attacks from -8 to 20 degrees with an increment of 0.250 with maximum iterations. That's the number of iterations used to check the conversion. And let's analyze this. Yeah, here you can just see the some points are unconverged. It will skip those points. Sometimes there may be error. For that, you need to just change the maximum minimum and change the increment value like 0.010. So you can like yeah. Yeah, I'll just stop for now and see. You can see all the plots here, and these are those colors on all those variation. You can change the color. For example, if you want to change the color of this TRE.080, you just need to select that with NACA 2412, and you can change the color here, color, and even you can change the style and points. All. For example, for now you want to analyze between these two, S9000 and NACA 2412 at Reynolds number of 100,000. So for just hide all ops, hide all polars, and select the polars which you want to see S9000 with Reynolds number 100, and just select the curve. It will show up here. I think it hasn't analyzed the negative part. In second I'll learn. Yeah, and now NACA 2412 with same Reynolds number 100,000 and select the curve. You can see these two curves, and depending upon your condition you can select any of the files. Like if you want more value for CL by CD, you need to select S9000. Similarly, let's just analyze the Reynolds number. I'll just hide all polar and show all associated polars. It will just show up the this NACA 2412 all the Reynolds number polars. Here you can see the like different polars. Here some transition is there. So below this polar, it's just a laminar flow, and above that, below this red color, which is 0 30,000 Reynolds number, it's laminar, and above that is a transition. For that condition, we have one type of analysis. We'll just do that. Now define an analysis and select user define and type 4 with a constant alpha. Let's just take 5 degrees and Mach number as 0 and everything else is the same, and okay. Now I'm starting it from 10,000 to 300,000, and I'll analyze this. You cannot find the plot. For that, we'll just increase the width. Here you can see the plot, and here. One more thing, for just seeing one polar, just select one, and second polar for 2 and 3, 4, like that. And if you want to see two polars, select T and A for all. Now let's just focus on two polars. Here I just want to change this to lift versus angle of attack, and this one as drag versus angle of attack. Here you can see uh, that Reynolds number analysis, and here this red one, you can see that above which some which are nearer and no bumps are there, and below the red is the laminar flow, and above which is a transition and it converts to turbulent. So you can see this irregular shape. For analyzing this, now we are analyzing the Reynolds number. Now let's change this alpha to Reynolds number. So I just show only the plot, hide all polars and the curve. You can see it here, and this one to Reynolds number. Here you can see sudden rise in the lift. This is not useful. So for greater performance, we need to run the foil in this range, that is 10 power 5 to 2 into 10 power 5 Reynolds number. So for improving this performance, let's just try with changing the analysis type. Let's just force transiting it to 0.3. So at the 0.3, we are making it to undergo transition, which can be done using by